Welcome back! Today we are going to talk about the human heart, and in particular we're going to compare the mass of it to the mass of the rest of the human body. So, I've discovered through some internet research that the average human heart has a mass of 285 grams. So that's the average human heart, average between the average female and average male heart. And the average human body is about 62 kilograms, or 62,000 grams. So what we're looking to find out today is what percent of the mass of the human body does the heart take up. So in this image we see that the heart is kind of in the upper center of the chest cavity, and we are looking to find out again what the percent composition by mass the heart is in the human body. So where to start? Let's start with our formula for the percent composition. So as we will remember, percent composition is equal to the part divided by the whole multiplied by 100. And to be clear, the units for the part and the whole must be the same units. That way they will cancel out to find the percent. So let's think about what we are going to insert into this equation as the part and what we're going to insert as the whole. I'll give you a few moments to think about that. So if you wrote down that you're going to use the mass of the heart as the part and the mass of the entire body as a whole, you are correct. So if we take 285, insert it into the part, and 62,000 grams and insert that into the whole, that will be our equation for the percent composition. So I will then have 285 grams divided by 62,000 grams times 100. And it is important to remember that our units will cancel out. And I'll give you a moment to calculate your final answer. The heart takes up 0.46% mass of the entire body. So the heart accounts for 0.46% of the human body's mass. So that's not a lot, that's a small portion. But if we think about just the heart now, the heart is a muscle. And muscles are made up of amino acids and protein. So here's an example of one possible amino acid. So amino acids are organic molecules that have a nitrogen. And if we use this one for an example for a possible amino acid, what is the percent composition of oxygen in this amino acid? So if we take a look at our molecule, there are 2 oxygens in the molecule, 2 oxygen atoms in the molecule. And the first step to find the percent composition will be to calculate the gram formula mass for the entire acid molecule. So we're looking for the gram formula mass of the entire molecule. So we know that we have 2 carbons in the molecule, so we can go ahead and multiply 2 by the gram formula mass for carbon, which is 12 grams per mole. Next, let's look at our 5 hydrogens, We have 5 hydrogens, so we can multiply 5 times the gram formula mass for hydrogen, which is 1 gram per mole. Now we have 1 nitrogen atom. So we can add 1 times the gram formula mass of nitrogen, which is 14 grams per mole. And last but not least, we have our 2 oxygen atoms. So we can go ahead and add 2 times the gram formula mass for oxygen, which is 16 grams per mole. So I'll give us a moment to add up our answers for the total gram formula mass of our molecule. And let's see if we know what our final unit will be for this step. I'm thinking that since all of the numbers we're adding together have the same units, gram per mole, that our final answer will also be in gram per mole. So I find that we have 75 grams per mole for this one compound. So now that we have the gram formula mass for the whole compound, we need to find for the part that is just the oxygen. So gram formula mass for the oxygen. And we have 2 oxygen atoms, so we can go ahead and multiply 2 times the gram formula mass for an oxygen atom, which again is 16 grams per mole. So now that we have both of those masses accounted for, now we can calculate the percent composition. So again, we're looking for the percent composition of oxygen in this entire compound. So our part is just the oxygen, which is 2 times 16, which I calculated to be 32 grams per mole, divided by the whole, which is the whole compound, which we calculated to be 75 grams per mole earlier. And now we can multiply that by 100. I'll give you a moment to finish up that calculation. So our part is the 32 grams per mole, which is just for the oxygen, and the whole in the denominator is 75 grams per mole for the entire molecule. I calculated this to be about 43%. So by mass, this molecule is 43% oxygen. Even though there are just 2 oxygen atoms, the oxygen atoms are heavier than the others, so they take up more of the mass. Again, 43% of the mass is oxygen. So let's compare that to our hydrogen. We have 5 hydrogen atoms in this molecule, and let's see if we can calculate the percent composition by mass of hydrogen. So we already know the whole, the gram formula mass of the molecule. Let's calculate the gram formula mass for all of the hydrogen. So we have 5 hydrogen atoms, and we can multiply that by 1, which is the gram formula mass of 1 atom. So 5 grams per mole is hydrogen, which is the part, and divide that by 75 grams per mole, which is the entire molecule. And it's good to see that our units are the same and we can cancel them out of the numerator and the denominator. I'll give us a moment to finish up our calculation. I've calculated this to be about 6.7%, so the whole molecule, hydrogen only takes up 6.7% of the mass. So let's compare the two. Oxygen, despite only having 2 atoms, takes up 43% of the mass, while hydrogen takes up only 6.7%, even though there are 5 atoms. We can see the difference in that hydrogen has such a small gram formula mass, and oxygen has the highest gram formula mass out of all of these different elements in the compound. Alright, well, thanks for joining, and we'll see you later.